All right, in this example, we are going to work 5.84 from our book about recidivism. In the Scientific American article, Reducing Crime, Rehabilitation is Making a Comeback, R. Doyle examined rehabilitation of felons. One aspect of the article discussed recidivism of juvenile prisoners between 14 and 17 years old, indicating that 82% of those released in 1994 were rearrested within 3 years. Suppose that today 6 newly released juvenile prisoners between 14 and 17 years old are selected at random. Assuming that the recidivism rate is the same today as it was in 1994, determine the probability distribution for the number Y who are arrested within 3 years. Okay, so this then is going to be a binomial random variable. So the probability of success, right, is getting rearrested within 3 years. So again, that's an example where a success, right, is not such a great thing. But again, we're just going to go with that, right, because it's just terminology that we are using for the problem. We are not, saying that's a success or anything like that in the ordinary everyday usage of that word. Okay, so a success is being rearrested within 3 years. All right, and so if that is a success, right, then the probability of success is 82%. Okay, so that's the number that they've given here. So P is equal to 82%, or P equals 0.82. Okay. Again, we're going with success being this because they give us that percentage. It's not like we couldn't do it the other way, but we're just kind of going with the way that the problem is worded. All right, and so it says now we are doing this with 6 people. We're looking at 6 different individuals, right? So our number of trials would be 6. All right. All right, assuming the recidivism rate is the same today as it was in 1994, determine the probability distribution of the number Y who are arrested within 3 years. Okay, we know that it's a binomial random experiment. We know the formula, right? The formula would be this formula here. All right, and we can go ahead and type that in. I have the one from the previous example here. So in this case, n is 6, so we still have that. The probability is 0.82, so I'll change that. So that is our formula, right, for the probability distribution, and that pretty much tells us everything that we would want to know. If you do want to generate a probability distribution, you can do that in Desmos by just making this little table right here, and then putting the numbers 0, 1, 2, 3, 4, 5, 6, and then you can not here but right here up at put P of X sub 1 like that, and this will give you the probabilities. So that's the probability distribution for this. Okay. All right. So in part 1, right, what do they want us to calculate? Determine the probability. Okay, that's it, the probability distribution. So we did that, right? We have both the formula and the table. Okay. All right, next up in part B, it talks about the mean, right? So we know that the mean is going to be n times p, right, for a binomial random variable. So in our case, it's going to be 6 times 0.82. So let's calculate that out. So we get 4.92. All right, so that's the mean of this random variable. They want us to interpret it. So what this would mean is that on average, right, we would expect about 4.92, about almost 5 out of 6 newly released juvenile prisoners in that age range that they give us, 14 to 17. We would expect about, on average, right, the average would be about 4.92 would be rearrested within 3 years, okay, if the recidivism rate was the same today as it was in 94, okay? So about 5 out of 6. All right, so next in part C, it says, if in fact exactly 2 of the 6 newly released juvenile prisoners are rearrested within 3 years, would you be inclined to conclude that the recidivism rate today has decreased from 82% in 94? Explain your reasoning. It says, hint, first consider the probability that y is less than or equal to 2. All right, so let's do that. We want the probability that y is less than or equal to 2. All right, so if y is going to be less than or equal to 2, that's the probability that y equals 0, or y equals 1, or y equals 2. Those events are all mutually exclusive, because you can't have exactly 0 people out of 6 arrested and at the very same time have exactly 1 or exactly 2 people arrested. So these events are mutually exclusive, and so that means we can use the special addition rule and just add these up. All right, and then we would calculate these out. Again, we have the formula here, so I'm going to move this up so we can see the formula at the same time. No. All right, there we go. All right, so we would calculate the probability of 0. So in Desmos, you just, if you have your formula punched in like I do, it would be P of 0 plus P of 1 plus P of 2. All right, and we get that that is equal to 0. 0.016. Okay. Okay, so and the question they want us to answer is that if in fact only 2 were arrested, right, would you be inclined to conclude that the recidivism rate has decreased from 82%? All right, so basically, right, what they're asking is, you know, this data is from 1994, right, and so if I went out today and did it, you know, things could have changed, right, since 1994. So if you go out and do this experiment and you find, you know, that you only get 2 people, right, that were rearrested, then the probability of that event happening is 0.016. That is a pretty rare event, right, that would happen if it is in fact true that the probability is 0.82. Okay, so this is a pretty rare event, and so we would say, hey, you know, maybe it has changed, right? And maybe this data from 1994 is not accurate today, and that wouldn't be surprising at all if things had changed in that time. Okay, part D, it says, if in fact exactly 4 of the 6 released juvenile prisoners are rearrested in 3 years, then would you be inclined to conclude that the recidivism rate has decreased, right, from the from the value in 94. So in that case, right, we would calculate the probability that x equals, let's see, what did they say now? They say exactly 4, okay? So probability that x is equal to 4, right? And so if we calculate that out, that's P of 4. So we get about 22%, right? Or 0.220 is the probability of that, right, that you would get exactly 4. So if you went out and did that today and you got 4 people, right, that really is not rare, right, at all. It happens around 22% of the time, right? It wouldn't be the most common thing that would happen, right? It would, but it wouldn't be that rare at all. The most common thing that happened would be you would, on average, get something close to 5, right? But getting 4 is not that rare at all. So in that case, we would say no, not really. There is not really any evidence that the recidivism rate is less than what it was in 1994. On the other hand, if you get this event, right, then you say, hey, that's pretty rare. Maybe that is some evidence that the recidivism rate has decreased, okay? So this example here just kind of illustrates where we're headed within this class, in that that's what we're going to do. We're going to take samples of data, right, and then compare, we can calculate the probability, right, of those events, and basically see how rare they are compared to with what is the known or believed to be the correct values. Okay. All right. So that is it on that particular problem.